Okay, the time value of money, part 2. So here's the, so we have just seen the present value equation. Okay, C divided by 1 plus R to the power T. Now we may refer to these terms as follows. So the future value factor is 1 plus R to the power T, the compounding factor. And the present value factor, which is the discounting factor, is 1 divided by 1 plus R to the power T. Good. So letting P0, I'll be using subscripts from time to time when it's convenient. When the subscripts are not needed, I won't be using it. I won't be using them. So letting P0 denote the present value as of time 0 of a payment ft of a value ft to be received at time t. Well, the present value equation is always as follows. Okay, so P0 times 1 plus R to the power T is equal to ft, or P0 is equal to ft divided by 1 plus R to the power T. So if we have a formula to compute the present value and we need to know the future value of something, we can always first compute the present value and compound the present value over t periods to obtain the future value. This will be very convenient when we deal with annuities. Okay, so some questions. So with the present value equation, we can find R, the interest rate R that gives ft starting with P0 over t periods. So here you have an example of the steps you have to go through to obtain the interest rate, the needed interest rate R that will help you achieve a goal of ft with an initial investment of P0 over t periods. Here's an example. So you are offered $12,000 today. You will receive a cash flow of $40,000 in 12 years. What return is implied with these two cash flows and the number of years? The return implied is 10.55%. Now, how many periods are necessary to transform P0 into ft when the rate of interest per period is R? So to obtain t enters the present value equation with as an exponent. To isolate an exponent, it's very convenient to transform everything into logarithms. So the formula in the equation in red here will allow us to isolate t, the number of periods. So the log of something to the power whatever is equal to b times the log of whatever. Because log is a function that deals with exponents. So this is why log of two terms that are multiplied together is equal to the sum of the two terms. Because in fact I'm looking for the exponent of something. Okay, when I multiply two terms, I always add. I happen to add so if I multiply the same number to different powers, so I'm actually taking this number to the sum of its powers. So this is why we can do these transformations with the logarithm. So I want f, I know r, and I have P0 in my pocket. So how many periods must I invest P0 to produce ft at an interest rate R? So first, I'm isolating 1 plus R to the power T, which is future value over present value. Then I take the log on both sides. If I take the log on both sides of the equation, the equation still holds. Okay, it's the function of the same term. So the t here can be put in the front of the logarithm, which means that the number of periods needed is the log of ft divided by p over the log of 1 plus r. So for example, how many periods are needed for p0 to double at the rate r? This is sometimes a rule of thumb that people are using. The rule of 72. So the log of 2 over the log of 1 plus r should be very close to 72 divided by the interest rate expressed as a number instead of a percentage. Why? Because ln of 2 is close to 0.69 and ln of 1 plus r is also a small number. So adjusting everything, it's very close to 72. So if your rate of interest is 12%, 72 divided by 12 is equal to 6. So it would take you 6 years to double your money. So you are saving with the goal of $120,000. So whatever that is, going to school, buying something, putting a down payment on a house. You have $40,000 to invest today at the rate of 8% compounded annually. How long will it take to reach your goal? So T is the log of goal divided by initial investment divided by the log of 1 plus the interest rate, so 14.27 years. Future value with multiple cash flows. Okay, so we entered the domain of annuities. So $100 are invested in an account earning 8% compounded annually. So a second investment of $100 will be made in this account in 1 year. How much will the account be worth in 2 years? So after 1 year, the initial investment is worth 108. So 100 plus 8% interest. We add $100 in the account. So after 1 year, at the beginning of the second year, there's $208 in the account. Everything in the account earns 8%. So at time 2, we end up with $224.64. Put differently, okay, so we have $100 invested at time 0 for 2 periods and $100 invested at time 1 for 1 period. So the first $100 earn interest over 2 periods and become $116.64. The second $100 earn interest over 1 period only and ends up at a value of 108 at time 2 for a total of 224.64. Same problem, but the money is placed in the account at the end of each period. So here we lose 1 period of interest. Okay, so 208 happens to be 224.64 divided by 1.08. Simply because all the money invested in the account this way earns 1 less period of interest. So everything is discounted by 1 plus the interest rate, and the future value is 208 instead of 224.64. What is now the present value of 2 payments of $100 to be received over the next 2 years? So the first payment will be received at time 1, and the second payment will be received at time 2. Well, there's one slice of $100 discounted over 1 period, 92.59, and the second slice of $100 is discounted over 2 periods, so that's 85.73 for a total of 178.32. So this would be an example of an annuity. So this is an annuity paying $100 over 2 periods at the end of each period, and the value of this annuity is $100 discounted once plus $100 discounted twice. Okay, throughout the course or whenever we study time value of money, unless stated otherwise, cash flows take place are realized at the end of a period. So if we are looking at the profit of a company, So profits are realized at the end of the year. When we borrow money, usually we don't make the first payment on the day we borrow the money. So usually, if we borrow money for a car and have to repay by monthly payments, the first payment will be made 1 month from now. Okay, same thing when we buy a house. We take on a mortgage. The first payment on the mortgage will be made in 1 month, not right away, not when we sign the mortgage. Some annuity dues, paying the rent. So we pay the rent at the beginning of a month. So this is an annuity due. If we could buy a rent for retirement, in which case money could be paid at the beginning of the year. Whenever payments take place at the beginning of every period, we will call this stream of payment an annuity due. When it's an ordinary annuity, payments take place at the end of every period. So an ordinary annuity is one where payments take place at the end of every period, annuity due beginning of a period, and a perpetuity is an annuity with eternal cash flows. Okay, now, what is the present value of an annuity?